Sorry, guys. Last stream was cut off. Uh, for some reason. So never mind. Let's start again. So we were trying to understand this bitwise operations. So before we go further, because there's a lot of bitwise operation being done in the contract, so it is better to understand what are bitwise and how does it work, right? So I'm just getting my head around like how does it work. So once we start with that, like once I get a better hold, we'll just move ahead and act to the actual code, right? So the general rule is that first of all, let me write it down that just a second. Yes, so 0 to 9, then A to F, right? A is 10 to F, which is 15, right? It's like base 16, right? So base 16 is like, how do you categorize? So 1 to 9 is like base of 10, and 15 is like we are taking one digit into 15s, right? Base of 15. Like for example, when we write let me do this. All right, let me do this. Let's when we do 1 to 3, right? So it's like a base of 10 where we are doing 3 to the power 0, 2 to the power 1, and then 1 to the power 2, right? Sorry, 10 to the power 2, which is like 100, and then 2 to the power, sorry, 10 to the power 1, which will be 20. Yeah, let's do this. Can I do this? What the hell is this? Yeah, so the hell is going on? I don't understand what's going on. Okay, never mind. Let's start with 3 10, 3, right? So we'll write that 3 to the power 10 into 0. Then we'll write about 2 to the power 10 to the power 1, and then we'll write 1 to the power 10 sorry, 1 here a second, 10 to the power 2. Can I differentiate? I can change colors, right? Yeah, so 3 to the power 10, 3 into 10 to the power 0, 2 into 10 to the power 1, which is 20, and 3, and then 10 to the power 2 gives us 100. Yep. And let's do this one, and we'll give it a title. What's understanding base 16, right? So let's understand this. Since we now get understanding of this, I'll just put it here. What the fuck is this? How do I change style? Now it was. Yeah. So we understand that what is base 16, that every digit has a power of 16, like it can go oh sorry, no, understanding base 10 and base 16. So now we'll go with an example of base 16, which is like we are translating what it is to 0x. Let's try here. Base understanding base 16, and what we are trying to convert is just a second, if I can take this. What is it? We are trying to convert hex to A, right? So since so let's go and do our maths here. Why the hell so what happens is I want to do this. Yeah, so a is by the way 10 to the power 16 to the power 0, and then we have to multiply by 2 multiplied by what is it 2 multiplied by 16 to the power 1, and then we make a distinction which is green, and I'll do it light green. Light green sucks, right? So it will oh no, what the hell. Yeah, so now it equals to 10 to the power 60 160, and we are doing 32 192 should be 192. Is it 160? Yeah. What the fuck? Oh my god. It will be 10, and 2 to the 16 is I'm so stupid. Yes, it is 42, because 10 16 to the power is gonna be 0. Then we are adding 10 to 32, that will be 42. Oh yeah, I'm so stupid, dude. So stupid. Yeah, that will be 42. Great. Let's understand the byte representation of 255. So they are saying that this is byte representation of wait a second, how do I do it? Make text color is gonna be red. It's gonna be white. How do I do that? Oh wait, let's just delete it, and I'll do what I'm gonna do is yeah, so it will be, oh my god, it will be 0 b around the should be 8. 1 2 4 5 yep. Yeah, so these are, this represent 255, since this is like power of 10, right? So let's understand this. So this will be 1 2 4 8 16 32 64 128. Then when we sum them up, then it'll be 255 250 sorry 255. Yeah, so this is what is going to be. And not flips bitwise, not bitwise not presented by this flips bits. So for example, now this becomes bitwise not will become this. So 0. Okay, and bitwise flips to this, and this to this. Yeah, it just switches the bits. Yeah, so bitwise not will convert 255 to 0 or 0 to 255. Yeah, and then we are trying to right shift, draw right shift, right? So let's say dividing okay, so when if we do right shift 4, then it'll drop 4 here, right? And let's I think this should be self-sufficient. I'll just keep them in segment, right? So this is it. Apply to message dot data dot length is a number called data, and then we are trying to flip all 256 bits. So it's a bitwise operation, right? So 256 bits, like they are consisting of 32 bytes, and hence we have like 256 bits, right? So here like for a value of 35 bytes we are flipping it, right? So and then we are dropping the lowest is the right one. We are like dropping the lowest 96 byte and keeping only the 160 bytes. But why are we doing like if you want to drop it, right, then resume. A small size. 96 bits. No, I did not understand this. Am I still live or not? Yep. High is the left side and right are the lower side. So right shift by 12. Sorry about that. So we are visualizing 32 bytes from starting from 0. 0 is laid out on the right and the highest is like on the left. Let's just note it down, right? Because I'm always forgetting about things. So right bits on the right are the lowest while the extreme left are the highest. Cool. Yep, that's done. So the example says that we are shifting 96 bits like shift to right. The effect is that rightmost 12 bits from byte 0 to 12, the lowest, right? The rightmost 12 bits drops and then the higher bits move towards the right side, which is towards the lower sides. After shift it becomes like this. So okay, Yeah. Mm. Call, we are taking the call data length, right? We are not taking the call data itself. We are just taking the call data length, message data, right? Which is same as call data, right? So we are taking the size, we are flipping the 256 bits. So let's suppose it's 100, then we are making it 0, whatever, and we are flipping all 256 bits. Bottom 12 bits are being removed and only 20 bits left. It's really taking. Okay, I don't really understand, right? But from what I let's understand this. Okay, so it's basically inversing, like flipping. Basically, it's like inversing the length and then right shifting 96 bits, keeping 20 bytes all once. Okay. Okay, so it becomes like this. Got it. Okay, then we are doing some bitwise operations, and here we are checking if oh, what's SOR? Let's understand SOR as well. SOR, right? So in the code, bitwise SOR operation. Oh my god, why does comparison and bitwise logic operations? But here I'm comparing. So how does it work? Let's understand it like deeply. I don't wanna just read. Okay, this does this. Let's so A and B is 0.